This is one of the important topic. Actually, the meaning of polarization is, suppose as the plane wave propagates in free space, the direction of the plane wave may be constant or may change. That is, we can say that the electric or magnetic field intensity of a uniform plane wave has a direction in space. This direction may either be constant or may change as the wave propagates. That is, both electric field and intensity and magnetic field intensity, or particularly as a plane wave propagates in free space, the direction of the wave is in a particular direction. That is, in a particular direction it may propagate, or the direction may change. The direction may change. So here it comes the polarization concept. What is this meaning of this polarization is, we can define for a plane wave, the polarization of a plane wave is the figure traced by the tip of electric field vector as a function of time at a fixed point in space. A fixed point in space. This is the definition of polarization. So the meaning of this is, suppose as the wave is propagating in free space, at a particular point in free space, I am drawing the resultant figure. I am drawing the E field figure with respect to time. So the particular orientation of this electric field, is nothing but polarization. So simply we can say that the polarization is nothing but the orientation of the electric field as the wave propagates in free space at a fixed point in space. One more thing is, polarization is defined for electric field vector only. Polarization is defined for electric field vector only, because the reason is the magnetic field we can obtain easily from electric field by use of Maxwell's equations. Therefore, there is no need to define its polarization separately. Actually, this polarization of a plane wave or polarization of a particular wave can be either intentional or a result of propagation through materials, because as the wave propagates, it will propagate through different materials. So sometimes this polarization is either intentional, particularly in military applications, the polarization is intentional, or it may result because of propagation through different materials. So the definition is, this is nothing but the orientation of the electric field vector. The orientation of the electric field vector as a function of time at a fixed point in space. And to explain this polarization concept more clearly, we will do an analysis. Assume a plane wave traveling in positive z direction. Suppose this is like this. This is x-axis, this is y-axis, this is z-axis. We know that for a plane wave, since the wave is propagating in z direction, Ez is equal to 0. Only Ex and Ey exist. Ex and Ey exist. This is direction of propagation. Suppose I am taking let Ex is equal to some E1, the magnitude E1 into cos omega t minus beta z. Ey is equal to some magnitude E2 into cos omega t minus beta z plus theta, where theta is the phase angle by which Ey leads Ex. Of course, this theta may be either positive, negative, whatever it may be value. So generally I am considering some positive value theta, where theta is the phase angle by which Ey leads Ex. Then what is the total electric field? Therefore, total electric field is nothing but, since we have only two components, Ax cap plus Ey cap. Therefore, E is equal to, what is Ex? E1 into cos omega t minus beta z Ax cap plus E2 into cos omega t minus beta z plus theta Ay cap. In the definition of polarization, what we specified, this is nothing but the tip traced by the electric field vector at a fixed point in space. So for mathematical simplicity, I am considering in free space at z is equal to 0. Because the wave is propagating in z direction, I may consider at any point. For mathematical simplification purpose, in free space at z is equal to 0, I am considering. Then what happens at z is equal to 0? What is Ex? Ex is equal to E1 into cos omega t, because z is equal to 0. Implies cos omega t is equal to Ex by E1. Then sin omega t is equal to square root of 1 minus cos square omega t. Trigonometric identity we know, that is equal to square root of 1 minus what is cos omega t? Ex by E1 whole square. Similarly, what happens to Ey? Ey is equal to E2 into cos omega t minus beta z is equal to 0 means that is 0 plus theta, cos omega t plus theta. So just expand cos omega t plus theta, cos A plus B. So if I expand this, I will get E2 into cos omega t cos theta plus sin omega t sin theta. It is a trigonometric identity. Therefore, Ey by E2 is equal to, what happens? Ey by E2 is equal to cos omega t. Cos omega t already we know. Cos omega t is nothing but Ex by E1 cos theta plus sin omega t already we calculated. Square root of 1 minus Ex by E1 whole square sin theta. Simplify this equation further. What I am doing is Ey by E2, I am taking this term to left hand side, minus Ex by E1 cos theta, I am squaring at the same time. Square is equal to, this root vanishes, 1 minus Ex by E1 whole square into sin square theta. Sin square theta. Simplify further. This is a minus b whole square. If you simplify, this is Ey by E2 whole square plus Ex by E1 whole square cos square theta also minus 2Ex Ey by E1 E2 cos theta is equal to, right hand side it is sin square theta minus sin square theta into Ex by E1 whole square. Simplify further. Ey by E2 whole square plus Ex by E1 whole square, take common. Take this sin square theta Ex by E1 whole square to left hand side, then common is cos square theta plus sin square theta minus 2Ex Ey cos theta by E1 E2 is equal to sin square theta. This is equal to nothing, cos square theta plus sin square theta value is equal to 1, we know it very easy. Ey by E2 whole square plus this is nothing but Ex by E1 whole square minus 2Ex Ey cos theta by E1 E2 is equal to sin square theta. So take this as a equation number 1, suppose. So this is the equation we simplified for a particular case where Z is equal to 0. What is the electric field? Now we will observe different cases. What happens? I am considering for a particular case. First case, case 1. Case 1. The first case one is, let Ey be in phase or 180 degree out of phase with Ex. That is, theta is equal to 0 or 180 degrees. In general, theta is equal to n pi. Theta is equal to n pi, n is equal to 0, 1, 2. Here one thing is, either E1 is equal to E2 or E1 not equal to E2. That is independent of amplitude. Independent of amplitude. Independent of amplitude. If Ey be in phase or 180 degree out of phase, that is theta is equal to 0 or 180 degrees. Then what happens to equation 1? Equation 1 becomes Ey by E2 whole square plus Ex by E1 whole square cos 0. Cos 0 is 1. Here theta is either plus or minus n pi, whatever it may be, plus or minus n pi. Cos 0 is 1 or cos 180 is 1. Cos 180 is 1. Sin 0, 0. Sin 180, 0. So this is minus 2ex ey by e1 e2 is equal to 0. Is equal to 0. One more thing here is this depends upon theta value. Theta is either plus or minus n pi. So here for more generality I am taking either plus or minus. More generality I am taking here either plus or minus. Therefore it becomes ey by e2 plus or minus ex by ex by e1 whole square is equal to 0. So more generally I can write this ey by e2 is equal to either plus or minus ex by e1, implies ey is equal to plus or minus e2 by e1 into ex. Therefore that implies ey is equal to some m into ex. ey is equal to m into ex, where m is either plus or minus e2 by e1, plus or minus e2 by e1. So if you observe this equation, this is nothing but a linear equation. Ey is equal to m into ex. That is, if you draw a figure, this is ex, ey. Ey is nothing but some linearity. It may be positive value or negative value. Ey is equal to m into ex. So the resultant field is in a linear shape. That is, if you substitute E is equal to Ex plus Ey. Okay. So it will resultant is in the form of a linear shape. In the form of a linear shape. That is, we can say that because what is the resultant? E is equal to Ex plus Ey. So Ex plus m into Ex. If you take Ex, m plus 1. That is also in linear shape. Therefore, we can say that as the resultant electric field is in a linear shape. So we can call it as a linear polarization. That is, when Ey, that is when theta is equal to either 0 or 180 degrees or generally plus or minus n pi, independent of magnitude, either E1 is equal to E2 or E1 is not equal to E2, the shape is a linear shape. So we can call it as linear polarization. That is, the resultant electric field is in the form of a linear shape. Suppose E1 is equal to E2. E1 is equal to E2 means what? Then what is the slope? Slope m is equal to 1. Slope m is equal to 1. Suppose only one component exists. That is, E1 is equal to 0. Only E2 exists. E1 is equal to 0. Only E2 exists. Then we can say that the wave is said to be polarized in y direction. Suppose only E1 exists. E2 is equal to 0. Then we can say that the wave is polarized in only x direction. That is, here only one component exists. Either Ex or Ey. In that case also, it is linear polarization only. Suppose in the first case where E1 is equal to 0, only E2 exists. That is y direction. We can call it as vertical polarization. Suppose in the second case where E1 exists, E2 is equal to 0. That is in x direction. We can call it as horizontal polarization. That is, both vertical polarization and horizontal polarization are special cases of linear polarization only, where one component is 0. Suppose if Ex is equal to 0, then it is a vertical polarization. Suppose Ey is equal to 0, then it is a horizontal polarization. So both are special cases of linear polarization only. Linear polarization only. Suppose here already we discussed both the amplitudes are equal. Both the amplitudes are equal. Then slope is equal to 1. That is the polarization is a linear polarization at an angle of 45 degrees. That is, this angle is 45 degrees if both amplitudes are equal. Slope is equal to 1. Slope is equal to 1 means 45 degrees. Both are linearly polarized at an angle 45 degrees. Suppose if the magnitudes are differ, then it will be at a particular angle. So this is the condition for linear polarization. So what is the condition? Either magnitudes are equal or not equal. If theta is equal to plus or minus n pi in general, we can call it as a linear polarization. Linear polarization. One more thing, if only one component exists, that is either Ex or Ey. Suppose Ex is equal to 0, it is a vertical polarization. Ey is equal to 0, it is a horizontal polarization, which are special cases of linear polarization itself. If both amplitudes are equal, still it is a linear polarized wave at an angle of 45 degrees. This is the conclusion of a linear polarization, which is very, very important.